Elon, thank you for joining us. Over the past few weeks, there's been enormous excitement surrounding SpaceX's plans for orbital AI infrastructure. Many people know Starlink, but now they're hearing a new name, Starmind. To begin, what exactly is Starmind?
Thanks for having me. The simplest way to think about it is this. Starlink moves information. Starmind is intended to process information. Instead of sending every AI request down to a data center on Earth, you do most of the computation in orbit and just send the results back down. That's the basic idea. It's a fundamentally different kind of satellite network. It will change how we connect globally.
So this isn't just another version of Starlink?
No. Starlink is a communications network. Starmind is designed as a distributed AI computing platform. The satellites would contain large amounts of compute hardware powered almost entirely by sunlight. They communicate with one another using laser links and collectively function like one enormous data center in space. That's really the key distinction.
Why put AI data centers in space instead of simply building larger ones here on Earth?
We're running into several constraints on Earth. Modern AI data centers require extraordinary amounts of electricity, land, cooling infrastructure, and water. In orbit, to first order, you have nearly continuous solar energy, especially in the right orbital configurations. There's no weather, no cloud cover, no land acquisition, no local permitting issues. And instead of cooling servers with millions of gallons of water, you reject heat through large radiators into space. It changes the economics over time if launch costs continue falling.
One criticism people immediately raise is cooling. Many engineers say cooling computers in space sounds impossible.
Actually, cooling isn't the impossible part. You don't cool by blowing air across servers because there's essentially no air. Instead, you move heat into radiators, and those radiators emit infrared energy into space. We've been doing thermal management on spacecraft for decades. This is largely an engineering optimization problem, not a physics problem. The biggest challenge is scaling the manufacturing and launch cadence, not inventing entirely new physics.
Reports mention an incredibly ambitious goal, possibly as many as 1 million AI satellites. That sounds almost unbelievable.
I mean, it does sound ambitious, but people thought thousands of reusable rockets or 10,000 Starlink satellites sounded impossible too. The important thing is manufacturing. If you can mass-produce satellites the way the automotive industry builds cars, and if Starship achieves the flight rate we're targeting, then very large constellations become practical. The goal is to think in terms of industrial scale, rather than individual spacecraft.
Will these satellites use completely new technology?
Not really. One thing people often underestimate is how much of this already exists. Large solar arrays, laser communications, power electronics, autonomous navigation. Many of those technologies have already been developed through Starlink. The AI satellites are, in several respects, actually simpler because they don't need some of the communication hardware that broadband satellites require.
How do you envision ordinary people benefiting from orbital AI compute?
Imagine asking an AI assistant to solve an engineering problem, render a movie, generate software, analyze scientific data, or train robotic systems. Instead of waiting for an overloaded terrestrial data center, your request could be processed by an orbital compute network powered directly by the sun. As AI demand grows, compute becomes one of civilization's most important resources. The objective is to dramatically expand that resource.
Some environmental groups are worried about orbital congestion. How do you respond?
Space is unimaginably large. Low Earth orbit is managed very carefully. We already operate the world's largest satellite constellation and perform collision avoidance maneuvers continuously. The engineering challenge is maintaining responsible orbital operations, not running out of room. That's something we take very seriously.
Finally, Elon, if everything goes according to plan, where do you see this 10 years from now?
Because I think we'll look back and realize AI infrastructure eventually had to expand beyond Earth's surface. Human civilization's energy consumption will continue increasing. Compute demand will continue increasing. Space gives us access to enormous amounts of solar energy without many of the physical constraints we have on Earth. Ultimately, this isn't just about building a better data center. It's about creating infrastructure that supports advanced AI, scientific discovery, and eventually a civilization that operates across multiple planets. That's the long-term vision.
Elon, fascinating discussion. It certainly sounds like SpaceX is trying to redefine not only spaceflight, but also the future of computing itself. Thank you for joining us.
Thank you. It was great talking with you.